Hi my friends, welcome again. Very important course today. I'm going to teach you all kinds of MOSFETs. And of course, we're gonna test good MOSFETs and bad MOSFETs. And for the first time, I'm going to share with you 3 methods that you can use to test all kind of MOSFET. So I'm going to teach you how to test this kind of MOSFET. We called it basically True Hall Technology MOSFET or THT MOSFETs. I'm going also to teach you how to test this kind of MOSFETs, 3 terminals MOSFET. This is basically SMD MOSFETs that we find in computer motherboard. I'm going also to teach you this kind of MOSFETs, 6 terminal MOSFETs, and also this kind of MOSFET, 8 terminal MOSFETs. Same time, we find it in the shape also, flat MOSFETs, and it could be smaller as you can see also. So this is MOSFET, those also are MOSFET. So guys, this is a complete course and this is the only video you need to master MOSFET testing without wasting time looking for how to test every type of MOSFETs in the internet. So let's get started. First, let's select the diode option in the multimeter. So let's begin with the big one. So I'm going to teach you guys how to test it, and also I'm going to know if this MOSFET is N-channel MOSFET or P-channel MOSFET using the multimeter, of course. For this kind of MOSFET, the first pin here is the gate, okay? The second is for drain, and over here we have the source. So guys, I'm going to show you many methods. For the first time you will hear about these techniques. So let's get started. First guys, you have to shunt between the gate and drain using any probe like this, or just use your finger like this, okay, in order to get correct values. After that, let's put the black probe here in the drain and the red probe in the source. Good, we get a reading in the multimeter about 560. So if I swap the probes, this time the black probe here in the source and the red probe in the drain, you see no reading. We have 1 in the multimeter, means this MOSFET is good MOSFET, and the type of this MOSFET is what? So the type of this MOSFET is N-channel. Okay guys, why N-channel? Because I find the reading when I put the black probe here in the drain and the red probe in the source. I find the reading, means this MOSFET is N-channel. And to understand more guys, for beginners, I can even draw for you the schematic for this MOSFET. Here we have the gate, okay, here let's see we have drain, and over here we have source. For N-channel guys, you will find a diode in this direction, as you can see here, like this, from source to drain. So the anode connected to the source, the cathode connected to the drain. That's why I get a reading when I put the black probe in the drain here, okay, black probe in the drain and the red probe in the source. So black probe here in the drain, red probe here in the source, as you can see. Okay, we get a reading, black probe in the drain, red probe in the source. But if I touch the gate guys, like this, and go and check again, we get no stable reading, means this MOSFET is good. So let's discharge the MOSFET again. I can even swap the probes like this guys, pay attention. Here we get a reading, do you see? This is the second method. Here we get a normal reading, as you can see, 460, this is normal reading. But if you touch the gate, the reading will be a little bit low. Do you see? 100. So this is guys the techniques and methods I'm sure you heard this technique for the first time. Sometimes when you touch the gate, you will get a buzzer, a continuity, but sometimes you can just get a lower reading. Let's discharge the MOSFET again and do it again. So this is normal reading here. We have 460. Once I touch the gate like this, I should get a low reading. Not continuity, but low reading. So this MOSFET is good, and this MOSFET is in channel because we get a reading. We get here 460 watt drop voltage. Okay guys, so this one here is good one. Okay, let's move on to another MOSFET. So let's see this MOSFET, guys. Okay, so always the same working principle. We have gate, drain, and source. Okay, so first of all, let's discharge the MOSFET by shunting between the gate and source using any probe like this, or just use your finger like this. Good. Now the MOSFET is discharged. Always the diode mode. Let's put the black probe here in the drain, the red probe in the source. We get a reading about 500. So let's swap the probes, the black probe in the source, the red probe in the drain. 1. Okay, so this one also is in channel. Let's recheck, because guys, now the MOSFET seems to be good, about 80% good. We find a reading between drain and source, but we should recheck using the second method. The black probe in the drain, the red probe in the source. This is the right reading. Let's touch the gate with the red probe. Rotate again. Low reading, good. This is a good MOSFET. Okay guys, if I shunt, okay, let me shunt again the gate and drain. Recheck again. We have to find 500. We have 500. If I touch the gate, I should find a low reading about 100. Let's check. 100. This is good MOSFET. Now the MOSFET is good 100%. But guys, let's shunt again the MOSFET. But when you check the MOSFET like this, between drain and source, you find 500 good reading. The MOSFET is good, but about 80%. You have to do the second test is by touching the gate using the red probe, and then recheck if you get a low reading, 100. So this is the method that no one told you about. Again guys, discharge the MOSFET. First step, check between drain and source. We have reading, means this MOSFET is also in channel. Let's pass to the second test to be sure that the MOSFET is good. Touch the gate, okay, and then recheck. We have to get low reading about 100. This is good MOSFET, 100%. This one also is in channel. I'm sure you hear this method for the first time. Let's see another one. This one, for example. First, for this MOSFET, its reference, as you can see, K2611. Okay, this one here, as you can see, a level N60ES. First, discharge the MOSFET. Second, the black probe here in the drain and the red probe in the source. Oh guys, this is a shorted MOSFET. Let's discharge this MOSFET like this and recheck again. If we get a beep in the multimeter, means the MOSFET is shorted. Shorted MOSFETs. Guys, this is shorted MOSFETs. I can even swap the probes and they will get the same reading. Or short MOSFET. This is a shorted MOSFET, guys. So this MOSFET is shorted. So here this one is shorted. Let's check this one, guys, also using the same working principle. And as I told you, this is the only course you need to master MOSFET testing. So this one also, guys, let's discharge it like this, and then put the black probe in the drain, the red probe in the source. Nice, we get already 500. If I swap the probes, guys, like this, one, good. Now the MOSFET is good about how many? About 80%. The MOSFET is good. To be sure that the MOSFET is good about 100%, I should do the second test. What is the second test, guys? So we have already here 500, a stable drop voltage. So if I touch the gate using the red probe, I should get a low reading about 100. Let's check. 200. Good. Means the MOSFET is good one. And of course, let's change it again, because we get the reading here when we put the black probe in the drain here and the red probe in the source here. Means this one also is N channel. This one also is N channel. Okay, guys, let's check this one here using the same working principle. Discharge the MOSFET, black probe in the drain, red probe in the source. We get a stable reading. Let's swap the probes. We get one. The MOSFET is good 80%. Let's be sure 100% by touching the gate like this. Okay, about 3 seconds, 4 seconds, and check. Low reading, good. This is good MOSFET. This one also is good, and of course in channel. Let's check. Yes, in channel, because we get a reading when the black probe in the drain and the red probe in the source. And of course, this is the rule. This one is N channel. Good. So the last one, guys, here, the last one, I hope this one is P channel. So basically the reference for this one, as you can see, we have, let's check the reference. So this is K2842. This one also, maybe this one also is N channel. This is N channel. Yes, I remember this reference also is N channel, but let's check it, guys. Anyway, I will look for other P channel MOSFETs. So let's check one probe first. Let's discharge it like this. Good. So the black probe in the drain, the red probe in the source, reading 460. Good. Let's swap the probes. Black probe this time in the source, red probe in the drain. One. Good. 80%. The MOSFET is good. Let's reach 100%. So again, let's discharge it. Okay. Black probe. Sorry. Black probe here. Okay, in the drain like this. Okay, guys, red probe in the source, good, stable reading. If I touch the gate like this and then recheck, low reading, good MOSFET, and of course N channel. And for this one, of course, this one is the shorted one. The only one that is shorted is this one. Even if I discharge it many times, it's still shorted. So this one is shorted. Those are good. All are N channel. And of course, guys, remember this schematic. Always for N channel, you will get a reading when you put the black probe here in the drain and the red probe in the source, and of course you will get about 500. It could be about 460, it could be 500, sometimes 600, sometimes 700, guys. Okay, but when you touch the gate using the red probe and then recheck again, this drop voltage will be decreased to about 100 to 200 or 300. So this test here, we check the MOSFET, 80% is good, but the second test here, 100% is good. When the drop voltage drop to 100 to 200 when you touch the gate, means the MOSFET is good 100%. And of course, in the next videos, I will try to find a MOSFET that is good 80%, but it cannot reach 100% when we touch the gate using the red probe. So that kind of MOSFET can work, yes, it can work, but it can cause intermittent failure. Okay, it can cause this kind of MOSFET that pass the first test, it could cause intermittent failure, but the MOSFET that pass 2 tests is the good one. We have here the dot. Do you see this white dot? Means this is the source and 3 pins for source, and over here we have the drain. So we can just put one probe here in the drain, the second probe in the source. We get a reading in the multimeter, as you can see. If I swap the probes, as you can see, we get above 1000, or you can get 1, means the MOSFET is good. Let's check, guys, one of these flat MOSFETs. Those basically we called it flat THT MOSFETs. Also here, as you can see, we have this white dot, means this is the pin number 1, 2, 3. So this is source over here, and over here we have drain. So if we put one probe here in the source, the other here in the drain, so we get above 1000. So let's swap the probes, guys. So the black probe here in the drain, this one in the source, we get a reading, as you can see, 450. This is a good MOSFET. Guys, this MOSFET is in channel Y, as you can see, because we get a reading when we put the red probe in the source and the black probe in the drain. This one, so let's check. This one also is in channel because we have here source, drain. Okay, so remember, guys, when you put the red probe in the source and the black probe in the drain, and you get a reading about 400, 500, 600, sometimes 700, means the MOSFET is in channel. By the way, often or usually you will find N channels in motherboard. Why? Because the N channels are more reliable than P channels. Let's move on, my friends, and test this kind of MOSFET. This is basically SMD MOSFET, 3-terminal SMD MOSFET. Basically the fourth one here, guys, the fourth one here is connected to this one here. So this is drain. Okay, this one is connected to this, the same terminal. So we have always gate, drain, source, gate, drain, source. Okay, guys, so let's put one probe here in the drain and the red probe here in the source. We get already about 100. Okay, so if I swap the probes, nothing in the multimeter. This is good MOSFET. Let's check this one also, guys. So the black probe here in the drain, the red probe in the source, we get about 400. This is good MOSFET also. This one, for example, black probe in the drain, red probe in the source, we get about 160 good MOSFETs. This is basically diode over here, guys. This one, this is not capacitor, this is diode. I can prove to you. Do you see white mark here? We have cathode, anode. Do you see? We get already about 600. If I swap the probes, Normally I should not get anything, but if I get about 1000, no problem, because the diode is connected to the board. Nothing. This is good diode. So guys, let's check this kind also of MOSFET. This is basically a 3-terminal SMD MOSFET. This is the smallest one. The same working principle. We have always gate, drain, source. So if I put one probe here in the drain and the other here in the gate, we get a reading. This is N channel. This is N channel. Why? Because the black probe here in the drain, the red probe in the source. This is N channel, guys. If I swap the probes, I should get nothing. I get 1000 normal. Why? Because the MOSFET is connected to the board. Okay. Do you see, guys? I know 100% that this information about 1000 reading in the board is unique for electronic repair basics channel. You cannot hear like this information somewhere else. What about this one, guys? Is it a MOSFET or not? No, guys, this is BIOS. Even if we have 8 pins over here, this is BIOS. Do you see the BIOS always is bigger than MOSFETs? Over here we have MOSFET and this is BIOS. The proof also is we have the super IO. The BIOS is usually near to the super IO. Of course, crystal also near to the super IO. Over here, my friend, we have a very small MOSFET. This MOSFET here and those, do you see the size? This is also MOSFETs. Okay, guys. So in motherboard, guys, you can find this kind of MOSFETs, HP MOSFETs, or those also flat MOSFETs, or those like this, as you can see, and this kind here. Always, guys, the same working principle, the same testing. So let's check those. So first we have to locate the pin number 1, the source. So let's locate the pin number 1. The MOSFETs are very small. Let me zoom in a little bit. Do you see, guys? Do you see over here we have a dot here? Do you see this dot and this white mark over here? For this one, for example, we have dot here. So this is the pin number 1. So do you see, guys, the 3 pins for source are connected together? Do you see the trace? Do you see the path? The gate is alone and these 4 pins are connected together. So let's check, guys. Let's check again. So let's put the black probe here. So because it is small, it is very small, I will put the black probe here in the inductor. Why, guys? Because the inductor is connected to the drain here. So let's put the black probe here in the inductor and the red probe here in the source. We get a reading 400. Good. If I swap the probes, guys, so I should put the black probe here in this capacitor because also is connected to the source. Let's put it here and the red probe here. We get, do you see, about 1000 normal, very normal, because it is connected to the board. Let's check this one, for example. So here we have the source, here drain. So drain, I will put the black probe in this capacitor and the red probe here. We get a reading about 500. If I swap the probes, of course, I will get, you see, about 1000, or you can, yes, 1000, or you can get 1. This is good MOSFETs, guys. So guys, just for beginners, absolutely for beginners, I will go deeper with you, show you in details the MOSFET pinout. Do you see, guys? Here we have a MOSFET. Okay, so I told you that this white dot or this dot over here means the pin number 1. So pin 1, 2, 3 are source. Do you see this trace here? 3 pins connected together. We have the gates isolate alone, and over here we have 4 pins connected together. Do you see? I can even prove to you, my friends. Let's do it for beginners. So here we have the pin number 1. So I will put the black probe here. Okay, guys? So these 3 pins are connected together. Let's check. The second, the third, do you see? Connected together. If I check the gate, no connection. Just these 3 pins. Those 4 are connected together. Let's put one probe here, DC. For beginners, of course. 3 pins connected together. So this is the MOSFET, my friends. So guys, I hope that you understand this video. Please don't forget to like, share, subscribe, and hit the bell icon for upcoming videos like this one. And for anyone who wants to accelerate learning, you can join me in my Patreon page. You can check my website, my Facebook group. All links in the description. Thank you very much and see you in the next video.